Okay, so you're working through some problems and we come across some situation that looks like this. And I say to you, hey, go ahead and solve this guy. Tell me what x would be in order for this expression to equal 0. And what we want to do, or what I would want to do, is I would want to start to factor this so that if I can spot its binomial factors, then I know from previous lesson that, you know, if one of these is equal to 0, who cares what this is, then I know that the whole thing will be equal to 0. And this will work if I can factor this guy. However, here we are, we have a situation where I'm looking for two numbers that multiply together to give me -3 and add together to give me 4. Okay, and what are those two numbers? Well, in order for me to see what the factors of -3 are, I can go, okay, it's -3 or +1 if I multiply, or I could have +3 and -1. And neither of those options give me a sum of 4. So here we've got a quadratic equation, and this equation, or the expression on the left-hand side, is not factorable. So what do you do in this situation? Because our first sort of place that we'd go with this is I would, I'd try and figure this bit out. But now that I know that I can't factor it, what do I do? So have a think, put me on pause, and is there maybe a strategy that you can come up with? What would you do to try to solve this? Here's the deal. Because I know that I can't factor this guy, what I'm going to do is I'm going to forcibly, oh man, I'm forgetting how to spell forcibly. I hope that's right. If it's not, don't tell your English teacher, okay? Forcibly, I'm going to make this trinomial. I'm going to do something called completing the square. Okay, and you'll know what that means in a second here. And the reason why we use this name is because what I want to do is I want to actually turn this into a perfect square trinomial. So if I was to change this to a perfect square trinomial, then I definitely know that I could factor it. I could rewrite it as something that looks like this, a plus b all squared. And then maybe I could manipulate that somehow. So that's what I'm going to do is I'm going to change this expression so that I do have a perfect square trinomial. And we're going to take a look at how we're going to do that. I know that I already have this middle term of 4x. I have this -3. And this -3 isn't really helping me out. But if I want to make any changes, because I have this equal sign, I just got to make sure that if any changes I make to the left-hand side, I have to make the same changes on the right-hand side. And as long as I'm able to keep that in mind, I can do whatever I want. I can add or take away or multiply, whatever, on either side, as long as the change is happening in the same way. So what I'm going to do is I'm going to take my x squared plus 4. I'm going to ignore the -3, and I am going to treat this as if, just like in our last lesson, remember how I had k? Okay, I'm going to pretend that I'm going to go ahead and throw k on this side. I still have this -3. And then on the right-hand side, because I've introduced this extra k, I just got to make sure I introduce that k on this side as well, whatever k is. K is a number that we're going to choose. And we're going to choose it very intentionally, because what we want to do is I want to create a situation where I have a perfect square trinomial. So I can take a look at k and say what values of k would make this expression a perfect square trinomial, okay? And that is going to be 4 divided by 2, which will give me 2. So that means that I'll have x plus 2 all squared. But remember that k value is coming from squaring 2, which will make it 4. So that means that here I will have x squared plus 4x plus now 4, which is my k, minus 3 equals 4. And what I'm going to do is I'm going to keep these guys together. This is x plus 2 all squared. I have minus 3 and I have equals 4. And now what I can do is I can push the 3 to the other side. And I will have x plus 2 all squared equals 7. And now this is starting to look like something we have solved in our previous lesson. If I want to solve this equation, I just have to take the square root of both sides. And I will get x plus 2 equals. Remember, when I take the square root of a number like this, I have 2 possible values. I have a positive solution and a negative solution. So that tells me that x will be equal to positive or negative 7, take away 2. And I want to verify this. I want to make sure that this solution is correct. So I have one situation where I have positive root 7, take away 2. And then I have another scenario where I have negative root 7, take away 2. And I just want to make sure that I verify these solutions in case I run into any sort of problems, or maybe I made a mistake, or maybe one of these roots is an extraneous root, which means that I might have been able to generate it going through the solving process, but perhaps when I go to plug it back in, left-hand side won't equal right-hand side. I don't know. We're going to find out. But you can plug that back into your original equation, the one that you started with, not the one that we made changes to, but the original equation that we started with from the very beginning. You want to try and plug those values back in to see if they actually work. So let's quickly do that. I have x squared plus 4x minus 3, and it should equal 0. So let's see if root 7 minus 2 does that for us. So I have root 7 minus 2 all squared plus 4 times root 7 minus 2. And then we've got, minus 3 equals 0. So let's see if that guy equals 0. Now, we worked with radicals quite a bit, so this is where the radicals will come in handy now. Root 7 minus 2 all squared. Remember, this is the same as sidebar. A plus b all squared is a squared plus 2ab plus b squared. Remember that? Okay, that's what's happening with this guy. That means that I'm going to have root 7 squared. That'll be like a squared. That's just going to be 7. Then I'm going to have 2 times root 7. So I'm going to have plus 2 times 2 times root 7. And then I'm going to have negative 2 squared, which will give me plus 2 squared, which is just 4. Now I made a small error here because this is supposed to be a negative sign. Because this is a negative sign. So that should make this guy negative. There you go. So there's your first bit. And then the next one is going to be 4 times root 7 minus 4 times 2. So I'm going to have plus 4 root 7 times, minus 4 times 2, which is 8. and then I have minus 3. So when I combine everything together, this is still 7. Here I will have minus 4 root 7. Here I will have plus 4 root 7, and minus 8 minus 3. So let's look at our like radicals. These two are like radicals. I have a negative 4 root 7 and a positive 4 root 7. So these will essentially cancel each other out. Then I have 7 minus 4, or sorry, not minus 4, 7 plus 4. So that's these two guys. So 7 plus 4, that gives me 11. And then I've got take away 8, take away 3. Well, that's actually just negative 11, isn't it? So that means that these cancel out, okay? And that, in fact, takes me to 0. So this first solution, we just verified. So this one works, okay? Negative root 7 minus 2, we can verify that as well. Make sure that that one's okay. So we have x squared plus 4x minus 3. Okay, let's throw that in there. It's going to look just the same, but it will have a negative in front. So I'm going to have this all squared plus 4 times this, and then minus 3. Okay. Again, same idea. A plus b all squared is a squared plus 2ab plus b squared. So if we keep that in mind for this guy, we're going to have negative root 7 squared, which will actually just become positive 7. Then I'm going to have minus 2 times negative root 7. So these will actually end up canceling each other out and just become positive. And I'm also going to have that plus 2 squared, that plus 4, right? It's going to look like that. And then when I multiply these guys, I'm going to get minus 4 root 7 minus 8 minus 3. So let me just repeat that. So I put it in the next line. Oops. Okay. 7 add 4 minus 8 minus 3. So again, same thing is happening. I got plus 11 and then minus 11. So those will just cancel each other out. Then I've got plus 4 root 7 minus 4 root 7. Those will also just, again, I'm back at 0. So both of my solutions, when I plug them in and I verify them, I find that they both work. So this one also works.